Hello and welcome back to the lab. Today on the bench we have a 7B71. This is a 200 megahertz delaying time base. So for this one on a it's designed really for a 4-slot mainframe. And it is the A side slot. So the delaying time base typically goes in A, the delayed time base typically goes in B. The difference being a dual time base. Here's the 100 meg version. The 500 megahertz and the 100 megahertz dual time bases. So these are the delaying and the delayed time. The 7B53A and the 7B92A. So this is destined for the 7700 frame that I actually have over at work. That has been sitting there for a while and currently doesn't have any plugins in it. So if I want to be able to use that scope over in the office, I need some time bases and some verticals for it. The 7D15 that I fixed is going to go into that one. That is at least the plan. But for now, we have to get this one fixed and calibrated. I didn't notice this, but the has a very unique design on the trigger vertical. I kind of like this. It's a gear reduced potentiometer, probably to get a more accurate trigger on the 200 megahertz. So I like that. But as always, it's a piece of vintage Tektronix equipment, so pop it open and let's service the switches, because those are always a sore spot in these. And then we will give it a once over, see if there's anything wrong with it, and then we'll see if we can get it to do something in a frame. Well, this is going to be unfortunate. We're going to have to avoid the warranty. This one comes from us from Tucker. Looks like down in Texas. I have no idea who they are. I don't know if that was a used equipment manufacturer or dealer or anything, but this does say recal is due in '99. So, and that's a looks like internal recal sticker from Tucker. So, I suspect we're going to need at least a little bit of adjustment, although things do tend to stabilize as they get older, so they start needing a whole bunch of adjustment, and then they need less and less and less and less and less until they're just stable. But gotta have data to back that up. I'll cut out removing the stickers and cleaning it up totally. We're going to get all the sticker stuff off, and then we will go from there. Well, that made a disaster of a mess, so I will get all this stuff cleaned up, and then we will be back. Well, as I'm looking through this, while I was taking ownership of it and getting all the stickers off, which made an absolute mess, I noticed there's not a lot of adjustment points in here, so I think the alignment ought to go pretty quick. I don't want to shoot myself in the foot. I said that about the 485, and that got me into trouble. That one decided to argue quite a bit. I was curious about this, and I wasn't sure what this was going to be, but we have a 100 DC working volts. So this entire silver block is a capacitor, probably a hermetically sealed tantalum, most likely, along with these caps here and this guy back here. For those that are finding the channel for the first time in this video, those are typically timing caps for the sweep speeds. They very, very rarely go bad, and unless you are absolutely sure these are bad. If you have one of these units, and I'm going to recap the whole thing. Do not change these unless you're positive they're bad. They're sold as a set. They have to balance with each other for the sweeps to be right. So if these end up needing changed, it can cause nightmares getting the front dial to reline up. The trigger control on this one is odd. I'm not used. That's a multi-stack pot. There's 1, 2, 3. There's 4 of them in there. So definitely not used to that. Not quite sure why they did that. As always, we have some Allen Bradley style resistors. These will be fine. Typically, the things in these plugins don't get stressed too much. I haven't found the tunnel diodes yet, but there's a multi-stack construction. There's a mezzanine board here, and then there's another board up here, and then there's even a board in the middle, so they may be hiding in the middle. Oh, no, there's one. There's a tunnel diode. So there he is right there. That's the trigger diode usually. Let's see. Here's our cam switches that will service. Get those all squared away. We have a couple more adjustments on this side, but nothing too crazy. Yeah, it all looks good. So we'll get the cover pulled off. We'll get the cover pulled off of this, and then we'll get at our finger switches. We have our grease, our white lithium grease that's in the barrel switch is completely dried out, so we'll be replacing that. This pot's got some problems. If you see this doesn't turn. This control is completely frozen, so we'll need to get that addressed. And all of our finger switches are actually on this side of the barrel, so they're actually easy to service on this one, so that's not too bad. We'll be able to get in there and get those cleaned up. Biggest challenge is going to be this control. I have a 7B92 that's suffering from the same problem. The pot is totally frozen. I've got the 7B92 troubleshot down to, I thought it was just going to be an alignment, so I didn't hit record on the camera when I started into it, and it turned out it's going to be a little bit more interesting, so I will record that one if there's interest. Let me know in the comments below. But the pot in the 7B92, not the A, the 7B92, is dead. So hopefully the pot's okay on this one, but it is completely frozen, so we got to crack that loose. So we'll get into that first, because that'll be a showstopper unless I can find parts or get that freed up. So let's see what we can do. Okay, well, as Dave Jones likes to say, I do wish this was Feel-O-Vision, because that potentiometer cleaned up real nice. I also got the barrel switch all serviced up, so that is good to go as well. So now the question is, does the pot still work, or did it get destroyed? So what we're going to do is we're going to just hook up to the wiper. Like so. And we're going to look for a moving reading. So I don't really care what the reading is, I just care that it is moving. 4.8K. $100 ohms. So, yeah. All right, so the pot still looks like it's still good. So we will get our switch cover bolted back down. Oh, and when servicing the switches, it is nice to unplug this cable and get this wire out of the way as best you can. It's not perfect, but there is room. So we'll just get this put back on without catching any wires. And then I will get a scope. We'll see if we get some sweeps. Okay, I've got the plug-in set up with the fixed extender. A nice empty roll of solder is the perfect size to keep it supported, so we're not putting too much pressure on the aging connector. All right, let's see what we get. We are on A and left. Turn this over to ground. Oof, that was a little bright. Well, it's running kind of slowly, but it's 5 seconds per division. So, yeah, it does say 5 seconds. Let's see. Here's some beam. Oh, wow. We have lots of position. Ooh, cool. AC internal and auto. So we have a trace, no delay, and independent delay mode. So it's sweeping. And the readout is correct as I roll up. So cool. This is the 7904 frame we did in a previous video. Oh, let's check the magnifier. So 1 millisecond. Turn up the readout. 100 microseconds. Yeah, so the magnifier is working. All right, so I can let this warm up for a little bit. At least a preliminary test says we're good. We get sweep on all settings. So while the gear warms up, I'm going to pull a service manual and see what we're going to need to service this. For time-based accuracy, as normal, I'm going to use the TG501 that's backed up by the rubidium reference, and it's the best we've got in the lab, so that's what we're going to use. Turn this off during warm-up so we don't age the tube, and we will give it about 30 minutes, and I'll see what we need to do. Okay, so we're checking the peak-to-peak auto. We're centered, and we have half a division of 50 kilohertz. I'll move up to the screen. All right, half a division of 50 kilohertz. And what we want to do is I want this to be up at about the 1130 position. And we should have stable triggering, and we do. So I don't need to mess. I do not need to adjust our R251. And now to check the lower end, we just move the trigger down to about the 630 position, which would be about there. We're still stable, so that is good as well. Now I need the 3 o'clock position. So we'll spin this over to 3 o'clock, and our triggering is good. Bottom side of the negative going pulse. Triggering is good. Upper side of the negative going pulse is also good. I'm just checking here right at the edge, so we're looking very good there. So we need to check sensitivity next, so we'll check negative sensitivity at 3 o'clock, and I need to readjust the signal source for less. We're looking for 0.3 divisions. Let me get that lined up. Zoom in here on the waveform. We're at 0.2 divisions. So, and I have triggering at 3 o'clock, and I should also have triggering around 9 o'clock. I do. We have nice and stable triggering, so the sensitivity is fine. Bit overachieving. Let's check. Actually, I need auto triggering. And auto is not fine. Peak to peak is. Need a bit more signal. There's 0.3 divisions. Bit too much. Come down just a touch. There we go. See if we can get it to trigger. Yes. Okay, there's auto. Straight auto. And again, we can achieve a stable display, so our sensitivity is good. Normal mode, we need to check that as well. I can get a trigger in normal. And on positive slope, I can get a trigger on normal. So that is good as well. I do not have a differential voltmeter in the lab, so I am going to skip the DC level centering, also not having to adjust anything in the trigger sensitivity. I'm really cautious of doing step 6 due to the fact that the trigger is working exactly as it should, and I don't have the proper equipment. I will work on getting that fixed. However, for single sweep mode, we're good. So we will move this over to single sweep mode. Actually, we'll AC this, hit the reset button. Okay, in single sweep mode, we have the reset button lit. Put signal in, triggered. Reset button is lit. And it triggers. So single sweep mode is working. And I can tell, it's kind of hard to see, but actually let me turn off the graticule lights. I don't know if the camera is going to pick this up. Actually, I could make this real easy and just turn the sweep rate down. So single sweep is working. Checking the triggering from the line. The trigger is triggering just fine on the line, so everything is good there. Okay, we are into the important one, which is the time-based accuracy. Peak-to-peak auto, AC internal, 1x magnifier, 1 millisecond per division, 1 millisecond per division on the time mark generator. Time marks. Turn on some illuminate. Yeah, we'll leave a little bit of illumination on. Time marks coming up. Gonna zoom the camera in. I'm off angle, but that actually looks pretty good. Let me look at it from straight on. No, it's a little off, but that is okay. We can adjust that. The adjustment is the sweep cowl in the front panel. Gonna have to loosen that potentiometer up. It is very, very stiff. I'm gonna call that good right there. I'm referencing the very top of the time mark peaks. Actually, that might be a little under. Now that I brightened it up, might be a little underdamped. That is about as good as I'm going to get it. I am not going to get much better than that. Okay, and since we did that, we need to check the magnifier. So 0.1 and 10x. How are we looking? Very good. Not looking bad. Okay, checking the 10x registration. So we're on 5 millisecond time marks. Actually, let me turn the readout on. You'll see noise every once in a while on the trace. That noise is normal when you have the readout on. It's just sharing sweep speed. If I turn the readout off, noise goes away. Readout on, and the noise comes back. So that's totally normal. Nothing to worry about. But we need to check the registration. So we've got 3 time marks on. And if I hit 10x, Our registration is off quite a bit. This should be in the center. So we need to adjust our 795. 795 is way down here, so this is what we're going to be adjusting. That's all it's going to let me adjust. Yeah, but it's way over now. This is going to be iterative. Ooh, I may have actually hit that one. Getting closer. Yeah, this is iterative. All right, set it for the middle. Yeah, see, it doesn't take much, so we want to move this by half. There. This is going to be off just a touch. Okay. Now I'm getting the hang of this measurement. So what it is you want to zoom position 1x adjust. Zoom position 1x adjust, and that's going to be about it right there. Cool. Okay, checking the variable time per division. We're on 10x time marks, or 10 millisecond time marks. And that is what we want. 2 divisions of spacing per time mark, so that is good. All right, 5 microsecond timing. And let's see. That's off a little bit, so we need to adjust that. That's going to be C53J. Oh, no, no. It is 530J. So I found 530L. So where's 530J? C530J is unmarked. This is C530L. This is C530J. This is the one we need to adjust for the 5 microseconds. And a low capacitance screwdriver. Let's see. Tweak my microcontrol here. My fine adjustment on the dimensions. That's going to be good right there. Using the top of the time marks. Next up is 2 microsecond timing. 2. And 2. Actually, the 2 microsecond looks good. I don't need to mess with that one. I will take it. Okay, here is the fun part. Make time marks go fast. Actually, that is a little slow, so fast. Okay. Well, as you all can see, these are the times. Since I'm not using the 184, I'm using the TG501. We can run it up the scale and see how it looks. We'll give it a bit more signal. Very strange. Well, for those who have joined us in the lab for long enough, when something behaves like that, we know what that is. That is a dirty contact. More switch cleaning. And after a bit of switch cleaning, we are back, and everything is working again. So, down 1. Looks good. Looks good. Looks good. Looks good. Looks good. That's good. We're good. This is looking very good. Sorry about the speeds. Bring this down a bit. So we're not blasting the tube out. That's good. It's running a little slow, but it's hard to adjust the time base when the timer hits because of how slow it is. So I'm just judging it on how it yeah. Like this one's firing at 0.8. Slow it down a little bit more. All right, we are good on the time base. Now we're going to check magnified accuracy, and then I'm actually going to have to call it on that one because I haven't done the 7B80 yet, so I can't test the delay time portion of this until the other time base is set, just because of how it works. So much better. There we go. Go a little faster. Bring this up a bit. I think we're pushing the vertical a little too far for the bandwidth on there because we're into, well, we're into 5 nanoseconds per division. So time base looks good in 10x mode though. So at least up to the point I can test. Thanks for stopping by the lab and taking a look at this 7B71. I'll be getting a 7B70 to partner with this, and when I get the 7B70 I'll finish up on the delay time accuracy, because I'll have to adjust the 7B70 first, then we can finish up this one. So in the future we will take a look at that. I'll have to source one and get it repaired, but that is something that we will be able to do. As always, I will be down in the comments, and more is on the way.